Hi, in this video I'm going to help you get started on the IP subnetting workbook if you're stuck or if you have questions. Now, if you've never done subnetting, it can be kind of confusing. Now I'm going to use and download the PDF format because the page numbers are set, and try to save this. I converted the PDF to Word, but some of the sometimes when you take the Word document, it will convert the files open, or I'm sorry, it'll convert the page numbers kind of wonky. So I just take this is my workbook, so I'm going to take my name. You can try the Word document, but what we have is about 12 pages that you're going to complete, and they're all listed here in the assignment. So we have our document downloaded. Welcome to my messy desktop. It's so messy. I can't even find where I put my, oh, right there, my workbook. Alright, let me explain subnetting. Now subnetting is one of the most confusing yet rewarding things in networking. You have to understand it. There are calculators and websites and tools out there, but if you don't understand how to convert binary to decimal or decimal to binary, and then how to break apart your networks, it is going to be difficult for you to sustain yourself in IT. So I'm using PDF, so I'm going to open up this. This is with PDF how I can type things in here. So obviously your name. Okay. Anyway, I'm not helping you with formatting, so if you get stuck on formatting of your Word document or PDF, that's something you'll have to figure out. But in the first pages here, it gives us our classes. A, B, and C are reserved for networking, and the first octet of any subnet address will define the class. So if it's between 1 and 127, then it's a class A. Now 127 is reserved for loopback addressing, so that actually is never going to be, unless it's a loopback address, is never going to be in the first octet. And then 128 to 191, and then 192 to 223. Now class D and E are valid numbers, but they're not used for networking, or they're reserved. So when you look at any IP address, it's going to range between 0 and 255. 0's not used, 255's not used. They're broadcast, they're reserved for broadcasting, and then 127 isn't used. So even though 0 to 256 is, 255 is 256 numbers, we really have 254 that any octet can go. Now we also have default subnet masks that correspond with this. So let's look at the first page. Now in the assignment in Blackboard it says complete page 1, binary to decimal conversion. So what we want to do is find out what the binary equivalent is. So any IP, let me just give you a quick example. I'll pull up a Word, an Excel document, and then also I better pull up my calculator because, whoops, sometimes I have a problem spelling or adding things up and spelling and talking apparently. But anyway, in come on Excel, when you look at any IP address, let's say, let's look at the workbook. 146.119 is the first thing. So let's say you have an IP address 146.119.53.84. So that's an IP address. Now you can tell certain things from this IP. First of all, you can tell that it's a class B IP, and that's because 146 is within the range of a class B, which is 128 to 191. And then with a class B, you have something called a default subnet mask, which is this. I'm just typing these notes as I talk. So you have the default subnet mask, which we'll look at next. And then this is a 32-bit addressing stream, and what you're doing in the first few pages is converting this, which is, well, you're first going to convert your 32-bit binary stream, such as 10010010 dot 011 dot whatever the next stream is and whatever the next stream is. So this IP address here, which is binary, has a corresponding, I'm sorry, this is decimal, dotted decimal. So this IP address here has a corresponding binary stream of 32 bits of ones and zeros. So what you're doing in the assignment in here is converting this 8-bit stream to its decimal equivalent. Now the way we do this is using, without a calculator, is we're going to use the basic table. I use 128 and 64, and you're basically, if you're looking, you're dividing this in half. 128, 64, 32, 16, 8, 4, 2, and 1. And you'll notice these are 8 bits. 1, 2, 3, 4, 5, 6, 7, 8 bits. So we have 8 ones or zeros that are going to represent or be placed in here. So if you're taking 146, well, let's do it this way. If you want to take this first 8-bit stream, 1, 0, 0, 1, 0, 0, 1, 0, right here, which was this first one here, this first 8 bits, and then you want to convert it into decimal. Anywhere that there's a 1, you add up. So you would have 128 plus 16 plus 2. That would be anywhere that there's a 1. So if you take 128 plus 16 plus 2, guess what? Your sum is 146. So the binary equivalent to that is 146. Now, on your worksheet, that's all that they're doing here. So when they're anywhere that there's a 1, you're converting these numbers. So the binary equivalent of all of these ones, guess what that one is? It's 256, because that's the highest it can go. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is your 255. I'm sorry, I think I said 256. Whoops, I'm in the wrong button. So here, this is 255. Now the same thing here is anywhere that there's a 1, you're going to add it up. So 128 plus 64 is 192. 128 plus 64, I would probably use Excel, it's a little faster, plus 4 plus 1 is 197, so 197. Dang it, I keep forgetting to move that. Oh, 197. Okay, so you can go, you get the idea. This one would be 16 plus 2 is 18 plus 1, so this is 19. I can do the easy ones. Oh, this is 129. See what I'm doing here? Adding 128 plus 1. So you just go through and convert binary to decimal. Now your scratch area, you can, you don't have to fill that out. I assume that you're not cheating. which I don't know how you could. Now, I think my conversion just didn't transfer over. But even though this is a little bit tedious, go ahead and go through it so you'll get the idea. Now this one, binary or decimal to binary, is exactly the opposite. So what you're doing is taking the 123 and converting to the binary stream. So this is where this table comes in handy again. Now if I have, when you're learning subnetting, these numbers here are extremely important to know. So we're going to highlight that. That's our table. Now what I have is, I want to convert, what I'm trying to do is convert 123, this one we ended up was 146, but what I'm trying to do is convert 123 to the decimal equivalent. So how you can do that is you can say, can I subtract, if I have, can I subtract 123 from, well, 128, see, 4 minus 123, without going negative? And the answer is no. So what that becomes is a 0. And then you say, can I subtract 64 from 123 without going negative? Let me put this here like this. So can I take 123 minus 128 without going negative? And you cannot do that, so that's a 0 in that first bit. Now can I take 123 and subtract 64 without going negative? And you can, so that becomes a 1. So now we have to do the math of that. So this is where I need my calculator. 123 minus 64 is 59. So now I say, can I subtract 59 minus 32 without going negative? And you can, so that becomes a 1. And then you do the math again. So 59 minus 32, 59 minus 32 is 27. So can I subtract 27 from 16 without going negative? And you can, so that is a 1. So 7, 8, 9, 10, 11. I have 11 left. 11 minus 8 without negative, yes, so that becomes a 1. 11 minus 8, not November 8th. No. 11 minus 8. Oh, you darn. I'm just got to write 11 minus 8 because otherwise it comes up as November 8th. And then 11 minus 8, so I have 3 left, so 3 minus 4 without going negative. You cannot, I have 3 left, so 3 minus 4 without going negative, no, so that becomes a 0. And then I still have 3 left, 3 minus 2 you can do, so that becomes a 1. And then I have 1 minus 1 left, and you can do that, so that becomes a 1. So the binary equivalent for this decimal number 123 is this: 0, 1, 1, 1, 1, 0, 1, 1. I'm going to take this and go over to here, and that becomes my answer for 123. Now if you want to check that and add it all up, I guess we could write it out like they do, all spaced out, but you could do it like that. If you wanted to check that, we could just pull up a calculator, and anywhere there's a 1 we can add it up. So I have a 1, so this is in the 128 spot, this is in the 64 spot, this one is in the 32 spot. So anywhere there's a 1, I'm going to add it up. So 64 plus 32 plus 16 plus 8. And then I have no 4, but I have a 2 and a 1, plus 2 plus 1 equals 123. So looking at my next one, I want to convert 50. So again, I'm going to go back to here, and right now I'm working on 50. Now can I take 50 minus 128 without going negative? No, so that's a 0. I still have 50 minus 64. 50 minus 64 without going negative? No, so that's a 0. And then 50 minus 32 I can do, so that's a 1. And then I have 18 left. 18 minus 16 without going negative I can do, so that is a 1. And then I have 2 left. 2 minus 8, doggone it. 2 minus 8, no, can't do because it's negative. 2 minus 4, no. 2 minus 2, I can do because I'm not negative. And then the rest are just zeros. So the binary equivalent of 50 is this. I wonder if that will can take over. Oh, that transferred over kind of nicely. Just copied all my blocks. So that's the binary equivalent of 50. 255, do we know what that one is without using our thing? We sure do. 1, 1, and you can just type in your 8 ones. 1, 2, 6, 7, 8. 10, we could probably do this without a 0, 0, 0, 0, 1, 0, 1, 0. That's 10. That's me doing quick math. Fancy, huh? But some of these, you know, this one is easy. 1 is easy. 0, 0, 0, 0, 0, 0, 0, 1. Woohoo! Okay, so go ahead and finish that out. And again, the most important thing when you're converting binary to decimal or decimal to binary is to remember this table. 128, 64, 32, 16, 8, 4, 2, and 1. Now this page you're simply addressing, you're simply putting down the class addresses. And again, it's repetitive, but it's stuff you need to beat into your brain. You must know it. 192 is a class C. It starts at 192. 148 is class B. 193 is a class C. So just go through and do your class addresses. In networking, we only go up to 224. So 223, 224 is D. So you should only be A, B. Well, they have 249 in the first octet, and that's class E. So I guess they're not just doing networking. But in networking, it's A, B, or C, but there's also D and E. So when you're doing this one, again, you're looking at the first octet only, and that tells you what class of IPs you're in. So what did we decide this one was? Class B, class C, class B. Whoop. Did I turn that off? No. Okay. B, C, class A. Okay, so go through and do that. Now, that was page 3. Let me look back on Blackboard. So we have page 1, 2, and 3 explained address, network, and host identification 4. So on page 4 of my document, this is this page here that I want you to do. Circle the portion of these addresses that are the network portion and then the host portion. And this is going to be based on the IP class address. So you assume there's no subnetting going on. Now, if you're using Word or whatever tool you're using, you'll need to just highlight things to select the host part and the network part. So let's see, somehow mark it like I have what this works. Okay, I guess I should have paused for that. Okay, the network portion, so what we're going to look at here is just that we assume no subnetting is going on. So what you need to do is look at the first number. So 209 is class C. Now, with the class C, by default, the first 3 octets are the network portion. So you can come in. That would be the network portion, and then the host portion would be the back part. So what that means is that when you go to IANA or ICANN and you get a range of IPs, they're going to give you, I can't write on there, they're going to give you a, oh, where did that go? They will give you a class of IPs. So they say, okay, you're the, now I really screwed that up. They'll say you're the 209.240.80 network. So that would be your router network, your router IP. And then all of the things that you as a network administrator can control is these last 8 bits, which is what the 78 is. And that's all based off of your class. So when we look at 199 again is a class C, so by default this is the network portion. 117 is a class A, so this is the network portion. And then 215 is a class B. 215 is a class C, so again network portion. 192, that's a class C, so the first 3 octets. And then 95, I'm trying to get to class B. 158, here we go. So 158 is a class B, and the first 2 are network portion. Now over here, the host portion is kind of the opposite. So 198 is a class C, so this is the host portion at the back. 223 class C, this is the host portion. And again, what that means is, let me pull up something I can draw on. Again, when you go to, and get your class of IPs, so let's say they give you, let me just look, 198.125.87. So here, they give you that one. So here is your, keep going away. Whoops. So here's my router, and they gave me that first IP. Let's look at my paper copy. So they gave me, it's a class C, so I have no subnetting. So I would assign my subnet, my router, this address, 198.125.87.0. This is my host part. This is my network part. Excuse my wording. And then this is my host. What that means is the host part is, so this is my fancy drawing of a router, and then my host part are all of my computers on my WAN or LAN or what have you, and they, as an administrator, I can do whatever I want with the host part, but the network part's not going to change unless I do subnetting. So this IP would be 198.125.87.1, and then this one would be .2 and .3, but they all would start with the first three, and then the host is, these are all my hosts part of the network. That would be the last octet of that. And it's all based on the class of IPs. So going back, 17 is a class A. So as an administrator, I can do whatever I want with these three octets. Now in a class A, what you can see is that I have much more room. In a class C, if I'm only given the last part here, I can only range from 1 to 255, and that's not used, so 1 to 254. So on a class C, I only have 254, or 2 to the power of 8 bits. On a class A, I'm given this number, 17.0.0.0. That's my host. That's my fancy router here, not host. And then as an administrator, I have this one I can do anything with, this set of bits, and this set of bits. How many bits is that total? 8 plus 8 plus 8, 2 to the power of 24, 16 point some odd million IPs. So as an administrator, this computer could be 17.1.1.1. This computer could be 17.1.1.2. This one, 17.1.1.3. And in this octet, it can go from 1 to 255. And then in this octet, 1 to 255. And this one, 1 to 254, I should say. And that is where we get how many IPs we have, which is millions in a class A. So, I'm explaining probably way too much. I wanted this to be a short explanation. Class A, again, is a Class A, they give you the first one, so these are my host portions. And so on. 155 is Class B, so it's the last two. So go through, do that, zip through here. Network address, we're going to do this one as well. Let me just make sure. So now we're on page 5 of the network addresses. Now what we're doing here is 192, let's see, what are we doing here? Using the IP and the subnet mask, write out the network address. Alright, once we get into subnetting, we have a default subnet mask, and then we have subnetting going on. So when subnet goes on, we're changing our default subnet mask to something different, and it doesn't always have to look like it, like it's a Class A or Class B. Now here, let me get back to my text document. So here I have 192, and then I have 255, 255, 255. Anywhere there's a series of ones, which is what 255 is, that means that that is my network. That is my network address. So this one would be 192 .149.24.0. And then I'm going to 150, this would be 150.203.0.0. Anywhere there's a series of ones, that becomes my network address. Now if we look at Class A is 10, there's no subnetting. For example, let's look at this one. 28 is a Class A because it goes from 1 to 27. Now the normal default subnet mask is 255.0.0.0, but I have 255.255, so that tells me that subnetting is going on, and this is my network address. Now there's a ton of resources on the web. There's a ton of videos that might explain it better than I do that you can Google or look on YouTube and find. Or maybe you've done subnetting before. This page, this subnet document is really a great tool to help you pull together and practice subnetting, so I would recommend you keeping it. Host addresses. I think we're doing this one as well. Okay, host address is just the opposite. Oops. Host address is just the opposite. So you're going to, based on whatever the subnet mask is, the host address would be like this 0.0.0.11. Anywhere that there's no zero or no series of ones, that would be the host address. And again, they're not always using the default. Next page, this is the default subnet mask. So again, we're just really drilling this into your head. The default is based on the first octet. So 191 is a class B, and a class B, going back to the first page, a class B default subnet mask is 255.255.0.0, and these are all defaults. So you look at the first octet and you figure out the class, and then you put in the subnet mask. Class A is 255.0.0.0, Class B is 255.255.0.0, and Class C is 3 255s, so 255.255.255.0. Sorry, that was a huge sigh. I didn't think I'd take this long. 16 minutes left, so I better finish up quick. Okay, custom subnet mask, problem 8. Now, when you read through 8 through 18, it explains subnetting to you. And what it does is it works through several different problems and breaks down how it's done. And this is all stemmed out of understanding how to convert binary to decimal and decimal to binary. So we're going to do a custom subnet mask on page, I'm looking at these page numbers correspond with, they correspond with the PDF document, but it's called Custom Subnet Mask Problem 8. Now we need to have 3 subnets, and we need 45 usable hosts. So we need to, so all these pages super important to explaining how this is done. There are 2 formulas for calculating subnets. Well, to briefly explain the 2, this first one here, number of subnets equals 2 to the power of bits available. This are the subnets needed. This is what's most commonly used. This -2 method is used for old Cisco networking routers that didn't support different aspects of IP, but now they do, so we don't usually use that -2 at this point. So you can do either way. This explains whether to use the -2 or the 2, and it's all based on the version of routing protocols that's used. Okay, so all of this goes through and explains, gives you, I need 14 subnets, I have a class C, how am I going to break it apart? I better go get a plug. Hold on. Okay, got power now. Alright, so all of these problems kind of walk you through how to do one, and then it pulls different pieces out. So what I want you to do is do question or problem 8 and 9 and subnetting. So I got a few more minutes. I really didn't expect this to go so long. But we got a few more minutes, so let's look at problem 8 and get started on that. So what we're going to start with is we need 3 subnets. Now we have a subnet mask of, a network address of 200.175. So 200 we know is a class C because it falls in that range, so we can put that in there. And then the default subnet mask for class C, 255.255.255.0. And then the custom subnet mask is based on how many bits we want to borrow. So if we need 3 subnets, well, we have on a class, host, I'm just seeing what they need to do. Okay, if we need 3 subnets, and on a class C we have 8 bits that we can borrow. So the way I kind of look at it is that we have, let's go back here to use my pen. We had a subnet mask of 2. We have not a subnet mask. We have this 200.175.14.0, and the default was this. But what I need is 3 subnets. Well, if I can borrow 1 bit, so 2 to the power of 1 is 2. I could borrow 2 bits, 2 to the power of 2 is 4, and that gives me 4 subnets. Because I have 8 bits I can borrow, I could borrow 2 to the power of 3, which is 8 subnets. Now I only need 3, so you can see, let's borrow 2. So if I borrow 2 bits, then what I have is I borrow 2 bits from here. So now, instead of not borrowing any, I want to convert this 1, 2, 3, 4, 5, 6, 7, 8. I want to convert this into my decimal equivalent, and then that becomes my custom subnet mask. So 255.255.128 plus 64, 192. So back over here to my document, my custom subnet mask, in order to get 3 subnets, 255.255.192, which is 128 plus 64. Total number of subnets, well, we can't get 3 because you can 2 to the power of 1 is 2, 2 to the power of 2 is 4. These are how many bits. So we'll have 4 subnets. Total number of host addresses. Now these are bits that are left over. So if I borrowed 2 bits to get 4 networks. Now what are my hosts? Well, I had 8 bits, so 2 to the power of 6. That's how many bits are left. And it should be 64. So I'm going to pull up my calculator just to double check my stupidness. 2 to the power of 6. Right, 2 to the power of 6. I got too many zeros in there. $64. So this is how many hosts on each network. So I have 4 networks with 64 bits. 64 hosts. Number of bits borrowed, I borrowed 2 bits. And then the usable addresses, I think if they're doing the -2 or not. Let me just look at the questions above. They are. So the usable addresses are just 62 because they're doing the -2 or the -2 that aren't used. So do that one, and you're going to, number of usable hosts needed was 45. I was just looking back at this problem 8. Now that's okay because we have 62, so that'll work. And then my work was done on my scratch pad here. Okay, you're also going to do problem 9, and in problem 9, let's see, this is a 128 is a class B, the default 255.255.0.0, and the custom subnet mask is based on how many bits you want to borrow. So in order to figure that out, we have 16 bits available, right? .0.0. And again, I want to get 60 subnets. So you can take, basically, I'll just write it out and then I'll have to do the math. So I had 2 to the power of 1. I have up to 16 bits available. 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8. Now, this is where I need my, so we know 2, 4, 8, this one was 64, and 2 to the power 5 is 32. 16, and 128, and 255. So I need 60, what does this say? I need 60 subnets. So I need to borrow 6 bits. Number of bits borrowed, 6. Now what becomes of my subnet mask? Well, that's going to be, that's where we do our conversion again for our 6 bits. So what is this? 1, 1, 1, 1, 1, 1, 0, 0. 128 plus 64 plus 32 plus 16 plus 8 plus 4, 1, 2, 3, 4, 5, 6. So that should be 255 minus 3. It should be 252. I hate to be so stupid sometimes, but I gotta add this up. 128 plus 64 plus 32 plus 16 plus 8 plus 4. Did I forget one? 20, 28, 252. So my custom subnet mask is again 252.0, because I borrowed 6 bits. How many subnets did we get? 64. How many are usable? We have 64 total subnets. How many host addresses do we have? Well, we have we had 16. Remember, we had, this is a class B, so you got to deal with it differently. Instead of -8, we had 16 bits available, and we took 6. So we took these 6 bits to get our 64 network. So we have 2 to the power of 10. That's how many hosts we have left. So again, whoops, 2 to the power of 10, 1024. So number of hosts, 1024. Usable minus 2. Hey, I didn't mean to do that whole problem for you. Now, the last ones that I want you to do, you can give a shot on your own. There's subnetting. So we're looking at page 34 and 35. Which starts out the same way with the things we just learned. And then what is the subnet range? And then it breaks apart the subnet addresses. So do your best, and yeah, the ranges, it tells you what are the ranges of the host. So the first parts are the same, and then the bottom is the ranges of networks. Now one other, those two problems, page 34, read through this. I got a class to get to at 1:30, so that's why I'm zipping through. So the first part is the same, and then the ranges of subnets. So it'll show you how to break it down. And you need to do two of these problems, problem 4 and problem 5, I think I have. And yeah, 4 and 5. And then there's one at the very end of the workbook, things that are invalid, and those are kind of tricky, like maybe the number's out of range or it's a loopback address or something. Now one other thing I'll show you real quick is subnetmask.info. This is a great website where you can plug in and check your work and check your answers. So I did not, and now save your document, and that's what you're going to attach. Now I hope that was helpful. I didn't intend for it to be so long, but enjoy.